Particulate nature of matter. Experiments on matter. To investigate properties of matter, we need to carry out experiments. Our experiments will involve cutting a piece of paper, breaking a solid, dissolving a solid, and allowing water to pour or leak from a hole at the bottom of a container. Observe what happens in each experiment and use your observations to make conclusions about the properties of the material or substance used in each case. In this following demonstration, observe what happens as a piece of paper is cut several times. What can you say about the composition of the paper? Observe what happens when a hammer strikes a solid. From your observation, what does the solid consist of? Dissolving a solid. Click on the play button and observe what happens when potassium manganate 7 is added to water. Observe water leaking from a hole at the bottom of a container. What does your observation show about the nature of water? All these experiments involving the cutting of paper, breaking of a solid, and leaking of water show that matter can be broken into smaller pieces. We conclude that matter consists of particles. This is the particulate nature of matter. The movement you have just observed may be simulated as shown. What have you observed about the movement of particles? Conclusion. Particles of matter move continuously and in all directions or randomly. States of matter. Compare the spacing and observe the movement of particles in the three states of matter. Characteristics of solids. Solids have definite shape. Particles are more closely packed. Each particle vibrates, so there is no overall change in position. Characteristics of liquids. Liquids take the shape of container. Motion of particles is random with a little rotation and little vibration. Particles are less packed than in solid. Characteristics of gases. Gases have no definite shape or volume. Particles are farther apart than in liquids or solids. Motion of particles is random with a bit of rotation. Diffusion. Click on the play button and observe the behavior of gas particles. What can you say about the general direction of movement of particles? If the cover of a cooking pot is opened, the smell of the food soon spreads to other places. The process by which particles spread is called diffusion. Diffusion is the movement of particles from a region of higher concentration to a region of lower concentration. Diffusion in liquids. In the following demonstration, a drop of potassium manganate 7 solution is added to water. Observe what happens after the drop is added. Diffusion takes place largely in fluids, that is, liquids and gases. Activity 3. Diffusion in gases. In the following demonstration, One piece of cotton wool is soaked in hydrochloric acid and another in ammonia solution. They are then plugged into the two ends of a glass tube simultaneously. The photograph on the next page shows how the glass tube is clamped, while the accompanying animation shows the movement of particles. One of the bottles contains concentrated hydrochloric acid and the other ammonia solution. Observation: the two vapors diffuse from both sides and meet at point P to form a white ring. Ammonia particles are less dense and lighter than hydrogen chloride particles. Therefore, ammonia particles diffuse faster and travel further along the tube than hydrogen chloride gas. Conclusion: since we did not see the whole acid or ammonium chloride flowing, it is their particles that move to form the ring of ammonium chloride at point P. Diffusion is a further proof that matter is made up of tiny particles.